We've seen functions at work in MySQL, functions like concat, date format, and round. But these functions were all scalar functions, which worked with one single value. But now we're going to look at functions that work with a series of values and return one summary value. They're called aggregate functions. When a query contains one or more of these aggregate functions, the query is called a summary query. When you use the column names with these aggregate functions, it's not referring to each and every row's column value, but the column as a whole and all the values within the column. For example, if you ran the round function, which is a scalar function in a query, it would take every value individually in each row and round that number. You still have the same number of rows in the result set, and the item price of each row is just rounded. But with an aggregate function like average or AVG, it works on a group of values. So it would take the original prices of each item, average out all 5 items, the entire list of values in the column, so the average of all 5 items returns one single value. The result set would look something like this once the aggregate function ran. One summary value, which is the average of all the rows. Some of the more common aggregate functions are AVG, sum, min, max, and count. The all keyword is used as default without having to actually use the syntax. That means that all the data in the column or group is used with the aggregate function. You can use the distinct if you don't want duplicate values. This is usually used with count. If there are null values in the column or group of data, they're ignored by the aggregate functions. For example, here is a simple result set of some products. Notice that the ball and the Matchbox car are both $1.99. If we get an average of all the product prices, it would be about $5.67. Using the all keyword means the same thing since all is assumed with aggregate functions, saying we want to use all of the values in the average. But if we use the distinct keyword and run the same query, it eliminates duplicate values. So the ball and the Matchbox car of the value $1.99 will now only be counted once in the average calculation, not twice as it was before. So now the average is about $6.59. By the way, if you're wondering how to get the averages to look more like a currency amount with 2 decimal places, you can use a round function with the average function and a second parameter of 2 to round to the nearest 2 decimal places. Okay, let's take another look at how the AVG or average function works. Here's just a regular query with no aggregates yet. I'm showing it so you can see what data we have in this table. Let's say we have 1,000 employees and just a few are showing here. We've kept track of each of their salaries as they have changed over the years. We want to find the average of all the salaries for every single person throughout every year, every time it's changed. Now, if we use an aggregate function in our select statement, the average aggregate function is used there, and this number takes every single value that was in the salary column for all employees and averages them all together. So for every 1,000 employees and every time their salary changed, all those values are getting averaged together, and we see the average salary is around $64,200. Again, because average will get more decimal places than we need for monetary value, you'll sometimes see it used with the non-aggregate function round to get it down to the right penny amount. Notice we can't show other non-aggregate columns like first or last name because the summary information doesn't go with any one person, but a whole long group of people. So non-aggregate columns like that would not be allowed in the select with this kind of a query. Let's look at the sum function. The sum function adds a group of values together and returns the single value. Here is a query, again with no aggregate function in it. So it's not a summary query. Every single person in every single time range when their salary is changed is represented in the result set. Notice Simul Zimmel. He had his salary changed 6 times between 1996 to 2001. There to there. Going from around 65,800 to 72,500. When we use sum function this way, it's going to get everyone's salary, every value that was in the column. So let's look at that. So we're using sum, and it's going to have everyone's value that was in that whole entire column is added all together. So every single person and all their salary changes are all added together. So that's a pretty big amount there. We could use a where clause to filter down the results to get just the salaries of Zimmel, and then the sum aggregate function would be adding up all of his salaries and not every single employee's. But it's still a summary function. It is still taking a group of values and returning one single value for that group. In this case, it's adding up all the 6 different salaries of Zimmel and giving us one value derived from a group of values. The min and max function do just as their name suggests. They're aggregate functions that return the minimum values or the maximum values from a group of values. So if we were to query the salaries table and get the min and the max of all the salaries, we'd come up with the very largest salary of the whole list and the very smallest salary of the whole list. The count function will count how many values there are in the group of values. When we use the count function on a column name such as salary, it takes the entire column of salaries and adds up how many values are in that column. In this case, there are over 9,000 salary values in the table. If we use an asterisk here, we get the same results because it's counting how many rows there are in the salaries table, and it's the same number as how many values there were in the salary column. We could also use a where clause to get just the count of all the values that result from the filter of getting just Zimmel's 6 salary changes. Since the where limits this to one person, we can use the first and last name fields to show in the result set. Let's take a quick look at count with our simple products table. Remember, we had a total of 5 different products. 2 of them happen to have the same price of $1.99. If we do a count of all the products, we get 5, which is what we'd expect. But this is a good place to use the distinct keyword if we wanted to only count each unique product price once. So now we see with the distinct keyword, our count is only 4 because $1.99 was only counted once. Also, it's good to know that when you use count, it will ignore null values. So if we happen to have a null value for the baby doll product price, and then we ran a count on all the product prices, it would ignore any null values in the count, and so nulls are not counted. All right, in this query, there is a new group by statement. This will take the data in the table and group it together first. In this case, it's grouped by first name and last name. And then, after that, it will allow the aggregate function to sum on those groups. So, from our table data again, the group by is going to separate the data out into groups. In our case, it's going to be by first and last name. So all of Ficello's data, Zimmel's data, Bamford's, and Koblick's data are all grouped separately because that's how we told it to group it, was by their names. Then in those individual groups, the aggregate function will then run, which sums or adds up all the amounts in those groups, and each group will get its own row in the result set. A row for Ficello, Zimmel, Bamford, and Koblick. But the aggregate function still worked on a number of different values, but those values were grouped by first and last name together first, and then it would sum them up by group. So here we want to the average of not only Zymel like we saw before, but everyone's average salary over every time period. We could use an aggregate function of AVG or average, and it wouldn't get the average of everyone, but first it would see the group by clause that groups the data into lists of values that fit under the category first, and then run the aggregate function on those groups. In this case, the group was by first and last name. So for every single person, it would look at all the salary changes they might have had. For Zymel, that was 6 different salary changes. It would then average out those values, and since we have added the first and last name to the select statement, we could see what average goes with what person in our result set. You can only use these non-aggregate column names like first name and last name if you are already using them in that group by statement. Here's the sum function again, adding up all the values after it groups the data into employees by first and last name. We can see that the 6 times Zymel had his salary change, those values are added up together as it did before, but now every employee has their values added up as well because we're using the group by statement. Here's another query with group by. This time we're grouping by gender, not last and first name. We can see the average salary for different genders here. You can see how many cool ways you can group the data and get super useful information for our users by using this group by. The having clause works with the group by clause. The having clause has a similar purpose to the where clause in that it filters our results if certain conditions are true. But the having clause specifies a search condition for a group. Once the data is grouped by the group by, it then can be filtered according to the having clause. So the having clause limits the groups included in the result set. Let's take a look at the query on the left. The employees were grouped by name again, and then the average of each employee was averaged out. Then the having clause filtered out any group with a salary average of less than $68,000. So instead of all 1,000 employees showing, only 308 of their average salaries are included in the result set. They are the only groups with average salaries of over $68,000. Remember, having works after the data is grouped. Don't confuse it with the where clause. The query on the right uses a where clause to filter out data even before it's grouped. The where condition is applied to every single row. The query on the left was applied to just each group of rows. Therefore, the results are different and the number of rows returned are going to be different. There's also another difference between having and where. The having clause can include aggregate functions, as is shown in the query on the left, but the where clause cannot. This makes sense because the where clause is applied before the rows are even grouped, so you wouldn't have an aggregate function there. Also, the where clause can refer to any column in the base table, but the having clause can only refer to columns included in the select clause. This makes sense because having is filtering the summarized result set that has been defined by the grouping. It's not filtering from the base table. The with rollup operator is an extension of the group by clause. It summarizes data within groups on its own separate line. Here's a summary query that is summarizing the average salary by department. No rollup is included on this one. Now let's add rollup. With the query on the left here, if we add with rollup to the end of the group by clause, we see not only the average of each department, but the average of all the groups on the very last line. The null is there because a group of text or string values can't be summarized. So it doesn't know how to summarize a bunch of department names, but it can show the average of all those other averages above it. On the right is the same, except we're getting the sum of the salaries not the averages. So the roll-up summary row shows the sum of each department's sum added up on the last row. If you use roll-up with a group by that's using 2 columns, then you get a summary row for each subgroup as well. So we've grouped by department, and then within each department, the subgrouping of males and females within the department. So notice there is an extra row under each department summary, the 2 values, summarizing those 2 values of the male and the female. At the very bottom, there is still a summary row for the entire result set as well. So there is a look at how we can use aggregate functions within our summary queries.